Hi everybody, this is Sean O'Kane with ChipEstimate TV. We're here at the TSMC OIP Forum 2013 in San Jose. My guest today is Norman Chang, Vice President and Senior Product Strategist with Ansys. Thank you very much for spending a little bit of time today. Could you talk a little bit about your collaboration with TSMC in regards to the Ansys methodology flow, regarding and addressing the verification challenges for the challenges in power, the increased power, the signal and reliability at the lower nodes? You want to talk about that?
I'm with Ansys Apache. Apache was acquired by Ansys 2 years ago and focusing on the back-end signal, power, reliability verification, also covering the 3D IC area. So we have been working with TSMC for the past 12 years, starting from the TSMC reference for 4.0 until this year. And this year we are focusing a particular transition from the planar transistor structure to FinFET architecture.
Right.
And that's a big transition. And due to this transition, it has a couple characteristics of this kind of design. It has a higher local current drive. It has a lower leakage power, which is very good for the design. And also combined with a mobile platform in today's design that has many power domains and complicated design structure for the low power design. So we have to look at several areas. We have to look at the 16 nanometer FinFET in terms of the power integrity, like covering the resistance, IR drop, and electron migration. Electron migration including the signal EM and the power EM. So that's one of the areas that we are working very closely with the TSMC. And for the 3D IC area, that 3D IC this year is transition to vertically stacked dies compared to last year's silicon interposer-based design. So for the vertically stacked die, that among the die structure, we really don't know what's the temperature in the inner side of the stack. So that's why we need to do the thermal analysis, including all the dies and in the stack of the vertically stacked dies. And we need to identify what's the maximum temperature and what's the thermal gradient due to the low power design. So the thermal gradient can be larger than before, that on the tens of degree that we need to watch out. So that's one area we are looking at this year is for the thermal analysis. The second area is that for the 3D IC chip packaging system, now we have to look at where you insert the DCAP. You want to insert the DCAP on the PC board or on the package or on the chip for the global core optimization of the DCAP. And then the third area, of course, is the YIO performance, signal integrity. That's why we need to look at a simultaneous switching noise analysis, that including the hundreds and thousands of TSV model extraction with the irregular spacing.
So your 3D IC is geared to low power for a lot of these mobile devices, smartphones, even movies we download to email, because the low power is in great demand.
Right.
So you're addressing that through this technology.
Yes. So one particular feature that we put on this year, and for the investigation of this mobile platform, that interleaving with watching the movie, which takes a lot of power.
Right.
That your mobile phone will exhaust the power within 2 hours if you watch movie continuously, compared to reading the email, that then your mobile phone can last for 2 days. Right. So it's a very different thermal signature induced by these two different power modes. So if you have an interleaving sequence of operations due to the high power consumption mode combined with a low power consumption mode, then what's the final thermal signature that you need to take into account? So our tool can handle different interleaving sequence of operations with a high power operation combined with a low power operation and figure out what's the final thermal signature of the whole device, and which is important for thermal aware EM analysis and for the final sign off on the mobile platform.
That's wonderful. I really appreciate you spending a little bit of time
Yeah,
with us.
thank you very
Thank
much.
you, Norman. Stay here for a second. For Norman Chang, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV.
Thank you.
That's really, really, really great stuff that you're doing.